All right. In this example, this was the first example. We're asked to convert the point three, -3, -2 into r and theta into polar coordinates. So in any of these kinds of problems, my first suggestion is always to get a visual picture of what's going on. And so I think it usually helps and stop a lot of confusion or wrong answers that could pop up. Okay, so -3, -2. So -3 in the x direction, down 2 in the negative y direction. And there's our point. And so we're looking for the angle theta that gives us this this location, and then our radius is the length of this vector there. Okay, so this is the theta that we're looking for, and this is the r. One thing to note is that if you have a straight line, you recall from geometry in high school, the measure of the angle of a straight line is pi radians or 180 degrees. Okay, so you can tell that because our point is in the third quadrant, that we're going to be 180 degrees or pi radians plus a little bit more. And so really what we're trying to figure out is if this is my r vector, right? We're trying to figure out what is this little extra bit right here. Okay, so it's going to be pi plus some little amount right here, right? Some little amount. That amount is what we're needing to add to. Okay, and so how do we find that? Well, this forms a right triangle, and so and we know the absolute value of this uh, uh, y coordinate is 2, and the absolute value of the x distance is 3. So I know that tangent of that angle, I don't want to call it theta because that would be confusing. We'll call it alpha, I guess. Alpha is going to equal y over x, which is -2/3 over -3, which gives me a positive 2/3. If you plug this in, you're going to get alpha and solve for alpha. Alpha is going to be the arctangent of 2/3. So arctangent of 2/3, which gives us a numerical value of approximately 33 point, let's say 7 degrees. Okay, so that's roughly what alpha is equal to. And so in degrees, if I wanted to write this angle alpha, alpha is going to be 180 degrees plus that 33.7 degrees, which is approximately 213.7 degrees. Okay, so there's my theta. And now I just need to find my r. Well, the hard part was the theta. The r is going to be the sides of this triangle. It's going to be the Pythagorean theorem of this triangle. So I'm just going to use the fact that I have x squared plus y squared and is equal to r squared. And so this is going to be 9 plus 4 equals r squared. 9 plus 4 is 13. The square root of that then is my r because the distance is always positive. And so finally then -3, -2 written in polar coordinates would be written as square root of 13 and 213.7 degrees. Okay. All right, I hope that was helpful. And I'll see you in the next video. All right, welcome back. In this example, this is going to be example 2 for us. We're given the point 6.5 is radius and 227 degrees is the theta. And we want to convert this into x and y. To do so, this is a pretty straightforward problem. All we need to do is know that x is equal to r cosine theta, and y is equal to r sine of theta. And so since we're given both of those, we can just plug directly in, and we get 6.5 cosine of 227 degrees, and y is equal to 6.5 times 227 degrees, which is approximately, for x is equal to approximately -4.4, and for y that's approximately equal to -4.7. Okay, so this is the the result, and we should note in a similar fashion as we did in the example one, just to verify, just to kind of get some sense making of this. If we plot the point, okay, the theta angle is 227 degrees. So I know that this is 180 degrees, and this here is 270 degrees down here. So what that tells me then is that 227, uh, wherever that is going to be between those two. So I definitely know this is in the third quadrant, and the radius is a positive 6.5, so it's some distance. Okay, so that is my point. And if I look at the x and y coordinates, -4, y, negative x, negative y, gives me the same result in the negative x direction and negative y direction, which is quadrant 3. So intuition, that's just a quick check to see if sometimes we make a mistake with our signs or whatever. So you can tell this is pretty quick. You can kind of have that connection. Another way to do it just very quickly is to recognize that x squared plus y squared is equal to 6.5 squared. And then using the relationship tangent of theta is equal to y over x. You can solve this for y and plug that in. And then just recognize that the theta you're going to get is this little angle here, which is a reference angle. So you just got to be careful about going back with that. So it's a little bit more involved, a little more challenging, algebraically speaking, but it's another way to solve that same problem. All right, I hope that was helpful, and I'll see you in the next video.